Hello everybody, today we will be explaining VSEPR theory.
Okay, so we have our reference list over here on the left, and it's going to explain how we're going to end up finding the geometry of the molecule. The D represents how many domains are on the central atom, B represents the bonding pairs on the central atom, L represents the lone pairs on the central atom, and S represents what the actual geometry is going to turn out to be. Okay, so we're going to do an example of each different shape, and we're going to explain how we decided what the shape was. Our first example will be CO2.
Now, the first thing you have to do is you must draw the Lewis structure for CO2, which is C in the middle and two O's on each side, and they have double bonds in between them. In order to figure out the geometric shape, you only need to worry about the central atom, carbon. So what you do from here is that you find the total number of domains. Now, a domain is wherever there's a bond or there's a lone pair, such as over here, but you don't have to worry about on oxygen because this is not the central atom. Central atom is in the middle. So carbon, you may think it has 4 domains, but it actually has 2 because each number of bonds, double bonds, triple bonds, only represents 1 domain. So as you can see, carbon has 2 domains, and then we go over to our list, has 2 total domains. These domains, they're both bonded domains, which means they're not lone like these. And then we go over here to our chart, and that is a linear shape. So this CO2 is linear.
Okay, so our next example is going to be acetone, which is CH2O. So first we have to draw the Lewis structure. So C is in the middle, O, H, H. There's a double bond on O, a single bond on the H's, and 2 sets of lone pairs on oxygen. So then we look at the center atom, which is carbon, and you see that there are 3 domains, and they're all bonding pairs. So we go over to our chart over here, and we see 3 domains, 3 bonding pairs, 0 lone pairs, and that means that this molecule is trigonal planar.
The next molecule we are going to be doing is methane, which is CH4. Now, first thing you do is you draw the Lewis structure, which is C in the middle with 4 H's all around it, and with single bonds all in between. Now, you look here at your central atom, you see there are 4 domains. There are no lone pairs. These are all bonding, so you go over to your chart, you find total number of domains, 4. They are all bonding, so 4 bonding, 0 that are lone pairs. So that makes it a tetrahedral.
Okay, so our next example is going to be ammonia, which is NH3. So first you draw the Lewis structure. So N, H, H, H. There are 2 lone pairs and 3 bonding pairs. So you go over to the chart on the central atom and you find 4 domains, 3 bonding pairs, 1 lone pair. So it is trigonal pyramidal.
The last one we will go over is water, or H2O. First, like always, you draw the Lewis structure, which is O and then 2 H's. And make sure on your O you have these lone pairs, otherwise you won't get the proper geometric shape. Now, count up your total number of domains. You have 1, 2, 3, 4. You have 2 that are lone and 2 that are bonded. So when you go over here to your chart, you find 4 total domains. Then there you see that there are 2 that are bonded, 2 that are lone, and that makes this bent.
Okay, so in conclusion, when trying to determine the geometry that a molecule will take, first you have to draw the Lewis structure of the molecule, and then you have to count the number of domains on the central atom, And then you have to count of those domains which are bonding pairs and which are lone pairs. From those numbers, you look at your nice little table, and then you can figure out what the shape is from there.